Hello everybody. So in this video we're going to correct the OSPF lab we saw last time. So in this lab we have to implement OSPF routing protocol. So that I'm going to share the network topology. So we have 4 routers and 4 LANs, as you can see. So the first question, we have to configure San Fran as the enable password on every router. So we are going to do it for just one router because the same command can be done on all routers. So we're going to start with this router. As you can see, when I use the enable command, no password has been requested. So to implement the enable password, we have to do enable secret and the password. Next question, configure loopback interfaces on routers as below. So we're going to configure this loopback on router or on router. Okay. Enable. I have to pass to configure terminal, global configuration mode, and use the interface loopback 0 because this is the first loopback interface. IP address. I'm going to pass the IP address and I don't forget the subnet mask. In the other routers, RG's routers 6.2 interface loopback 0 IP address and subnet mask. Third router interface loopback 0 IP address (6.3). Last router is already done. Already. Okay. Now we are going to configure a description to different interfaces on a router. So in this router, we can use the show CDP neighbor to display directly connected devices, Cisco devices, because we are going to use CDP. So as we can see, the interface fast Ethernet 0/0 is connected to the LAN. Interface serial 2.0 is connected to RAN router. Connected. And the last interface serial 3.0 is connected to asymptote router. Okay, then console password. So line console command on global configuration mode. Use password command, Cisco, and login. San Jose as the VTY line's password. Line VTY 04 password login. Can use the logging synchronous command as well as in console line. This command will avoid that the command I type don't be written with logs. Okay, then we're going to implement now the OSPF protocol. So we're going to display the routing table using the show IP route command. As you can see, this router has only directly connected networks. So this router don't know or doesn't know or doesn't have an idea about remote networks. So we're going to configure OSPF using the router OSPF process number 1 can display IP address of this router on network. I'm going to start using the LAN network. Area 0. And 5.8, the subnetwork. And I don't forget the loopback interface to advertise it on OSPF 6.4. Okay, now I'm going to do the same thing in other routers. But before I forget, there's a security command that will prevent making neighboring on the LAN interface. So I have to do this command, passive interface fast ethernet 0, to avoid neighboring on this interface. For the loopback interface 6.1. Okay, passive interface, LAN interface. Okay, we can see here the log about the new neighboring with the router asymptote. Okay, third router. LAN network. Don't forget the loopback interface to advertise it on OSPF 6.2 and security command to avoid neighboring on the fast Ethernet 0.0. Last router. Six three. Now to display the different neighbors discovered on with this router, we want to use the command show EP OSPF neighbor. As we can see, there is 2 neighbors for this router. Every router has 2 neighbors. Show EP OSPF neighbor. 2 neighbors. Here. 2 routers. 2 neighbors. Same thing for this router. Now, if we display the routing table, show EP route, here we can see that there is some OSPF networks that has been discovered using the OSPF routing protocol. As we can see, for this network, we have 2 routes because from this router to join this remote network, we have 2 paths, and when the paths have the same cost, the OSPF will perform what we call equal cost multipath routing, because we have the same cost to reach this network from this router. The cost is 64 plus 64 plus 1. So the cost is 129. 129. 64, 64, and 1. 64, 64, and 1. So if we test, for example, which path has been selected to reach this PC 11, 11. So here we are testing the reachability with using the ping command, and the remote PC is reachable. To display the path, we use tracers command. 11. Sorry, tracers like this. So here, the path or the selected path, the gateway 5.5, 5.1, and we arrive to the remote destination. So from here, 5.5 is this, 5.1 is this, and then we reach the remote destination. If we try another try, as you can see, here is different. It takes the other or the second path. So one time, one path, second time, the other one. It alternates. So if we want to use just one path, if we want to prioritize one path, we have to modify interface bandwidth or interface cost. On which interface we're going to modify the bandwidth or the cost. As we know, when this router advertises this network for this router, it will send what we call LSA. So the LSA is received in this interface. Then this router adds the cost of this interface, because this router receives LSA from this router. So this router, we're going to advertise this network with cost 1, because we have fast Ethernet 100 on 100, we have 1. So it arrives here, and then this router, we're going to add this interface cost 64. So if we want to use this path, we're going to modify the cost of this interface. Serial 2/0 interface serial 2/0 IP OSPF cost, for example 1. So the new path cost will be 64 plus 1 plus 1. So 2 plus 64 is 66. So from this router, if we redisplay, this is the new cost to arrive or to reach this network. So If we test again from this PC, 5.5 and 5.5, we are using the same network path. Okay, I think that we answered all questions. So if you have comments, you can comment this video, and I believe this video was explained well. Thank you for watching.